if you're going to say that the angles are congruent, that RST and TUV are congruent angles, then you can say all right angles are congruent. But with hypotenuse leg, we don't need congruent angles. You just need to know that we have a right triangle. Are we good? All right, going on to 4. And again, I wish they were not marking these right angles. I wish they simply told you they were perpendicular. Then you use the fact they're perpendicular to declare that we are looking at right angles. So those two angles, both of them would be right angles. And then you can say they're congruent. So Bonamy and Camden, this is where we would need the congruent triangles, because here we're going angle side angle. Are we good on 4? Proceeding on. 5 should have been the fastest one. I think the 3-headed or 4-headed, I guess, congruent statement here threw some people off. But with the reflexive property, we can say ZD is congruent to itself. And then with that, we have all 3 sides. How's life? Can I move on? Like I said, all of these will always be on my webpage, so you can always go back and check it out later. Number 6. Okay, problems like this when you have overlapping triangles. When I first looked at this problem, when somebody first asked me a question and I glanced at it, I thought we were going to try to do this triangle congruent to this. I thought I changed colors. Congruent to this triangle. That's what I thought we were going to do. But if you look at the statement, we're trying to show the MON, triangle MON, this triangle is congruent to this triangle. Okay? So it may not be a bad idea. It may not be a bad idea when you have the overlapping triangle thing and it's not obvious what the 2 triangles are. If you have colored pencils or a highlighter or something like that, it may not be a bad idea for you to just lightly fill it in so it's easier to visualize and lock in on those. And then
Why would they draw a line? Why would they draw a line between any?
I don't know, just to throw you off. Yeah. So once I've got, they gave me an angle. They gave us a side, MO and QO. So once we have an angle and a side, we can use vertical angles. And with vertical angles, we have angle, side, and we're done.
This is like kind of a random question. Like,
okay.
If you're like, so if the goal is like you're just like angles, can you say like if you know that the things are congruent, can you just prove it by like if it's like side, side, side? Can you just say by side, side, side?
What are you proving by side, side, side?
So it's like if you're trying to like prove like an angle equals another angle, and like you know like all of the sides are.
Are you doing tonight's homework?
Yeah.
Well, let's wait until we get to it. I was like, you said, it sounds like you're asking exactly what we're about to go over. Hold on. I like the enthusiasm. Well, then, all right, let's move on to 7. So we have the given information, and the instant I see a mention of a midpoint, I will immediately start looking for what that midpoint is making congruent. And in this case, it would be both the segments NX, XR, and AX and XG would be congruent as well. So that gives us 2 sides, and we can very quickly, hopefully by now, very quickly, see the congruent angles with the vertical angles, and we have side, angle, side. Good?
Yep.
Moving on! And 9 is the last one. FG and KL. FG and KL congruent. We have that. We have our parallel line. So as soon as you see parallel lines, go ahead and start thinking about a transversal. And if you have to, if it helps you visualize it, get your pencil and extend the parallel lines. Extend the parallel lines. And we have this transversal that's part of both triangles, and it may make it easier for you to identify where your alternate interiors and stuff are. Because some people may be tempted to look at this angle and this angle. But those are not the right angles we need to be looking at. We need to be looking at, let me erase all this, what we're ultimately looking at. Remember, you must draw your angles back to the lines that are actually parallel. It's those 2 that will be congruent by the parallel lines and alternate interior angles. And with that and the reflexive property, we have side, side, side. Yes, Ken?
Could you also do angle, side, angle, like for other alternate interiors?
Well, again, if you want to say these are alternate interior, you can say they're alternate interior, but they're only congruent if we know the lines are parallel. Do you know that FL and GK are parallel? And we don't. That's why it's so important that we establish parallel lines when we're doing that alternate interior. Are we good?
Good.
All right. Let's go on and knock out the 4 for today, and then hopefully we'll have a good bit of time. You can knock out the majority of the homework. So let's look at number 1. I have already input the given information. I've already put in the given information. And as I mentioned yesterday, if you want to be lazy with writing your given information in your notes or in your classwork or something like that, that's your choice. I'm not going to hold it against you. But you are running the risk of establishing bad habits that may accidentally repeat themselves on a test. I will count off if you don't write down the given information. So my recommendation is spend the extra 5 seconds it takes to write it down. You're not really saving that much time by not writing it, just for the sake of establishing that habit. All right. So I see a magic word. I see midpoint. And if I see the word midpoint, I'm going to automatically make note of what it is the midpoint of, or the midpoint of GJ. Therefore, GH and HJ are congruent. So there's my first statement. GH and HJ. Oh, man. I just dove straight into this. Definition of midpoint. Okay. I'm going to hit pause for just a second. Look at what we're trying to prove. Yeah, we're trying to prove that an angle is congruent to an angle. We're not proving congruent triangles, right? So what we're going to do, I'm going to go back for just a second. What we're going to do is we're going to first find congruent triangles. So for example, if I told you triangle PUT is congruent to triangle DOG. If I told you those two triangles are congruent, knowing that, you automatically know that angle U is congruent to what? Angle O. You automatically know that segment PT is congruent to segment DG. You automatically know that angle UTP is congruent to OGD. Y'all remember doing that?
So for this one, you have
So that's
to
what we're
find
going to do. So we have to find the triangles ourselves. Then we will use corresponding parts. And there was a theorem we talked about a long time ago that said that corresponding parts of congruent triangles are congruent. And it's shortened to CPCTC. And that's what we're going to use on all of these. It's on that reference sheet. If you have that reference sheet handy, it's on there. But that's what we're going to do on these. So we're trying to prove angles are congruent. Well, first I'm going to find congruent triangles. Well, I already have 2 sides. We either need an angle or a third side. And I see a third side. Because IH would be congruent to itself. Whoops, I don't know why I put lines above and below. Right? And so now I have side, side, side. But here you have to be careful here. In all of the previous problems, when we got down to having all of the correct information, we could simply copy the proven statement to know what the congruent triangles are. We don't have that here. We have to come up with it on our own. So give me one of the 2 triangles. Okay, I heard GIH first. You have the freedom to call it whatever you want for the first triangle. But once you have established that, you have to make sure that when you name the second one, you are lining up their corresponding parts. So GIH and JIH would be the same. We should not have G's and J's in the same problem. Throws me off.
So like when you put the thing that you have to prove, you just put like by side, side, side again.
Sure. Oh no. You put CPCTC.
You put C.
CPCTC. CPCTC. Corresponding parts of congruent triangles are congruent. CPCTC.
This says it at the top of the paper.
CPCTC.
Yeah. Actually, look at the top of the paper.
Yeah, that's not confusing.
What?
Is it the homework or is it the?
It's the homework.
Or the
And
okay.
It's both. It's both.
I would say it's probably on both. At the title. Look at the title at the very top. The title where
Where? Oh.
CPCTC.
Yeah. Yes, Grace.
Is this literally what we did yesterday?
Yeah, it's just that one extra step. So now, and don't just blindly write it down. Double check and make sure that what you're showing as congruent are in the same position, and they are. G and J, we both have listed first by CPCTC.
CPCTC.
Good. And as Grayson just mentioned, it's exactly what we did yesterday, just with one extra step. Some of them will have 2 extra steps, but there's not a whole lot more to it. All right, look at 2. I see, parallel lines. We're probably going to use one of those angle relationships, and it's almost always alternate interior. One of these days, we need to get like a corresponding in here just to remind ourselves that it exists. No mention of bisectors or midpoints. We do have angles already marked congruent. What do you want to do next?
QT.
I do too. I'm doing QT and QT congruent. Cutie. And that's reflexive.
And angle SQT.
Okay, I hear SQT and
QTR.
QTR. Do we agree with that?
Yes.
Yes. If you look at how we drew those angles, we did draw the angles to the lines that are parallel. Do not try to do these angles. Okay, that doesn't include a parallel line. So angle SQT, and make sure you name them correctly. The vertex has to go in the middle. Angle SQT is congruent to angle QTR because
if lines parallel and alternate interior angles.
If lines parallel, alternate interior angles congruent. And okay, with that, I have 2 angles in a side.
So angle side.
So this is angle side. And again, you have to be very careful on how you name your congruent triangles because the order, once you establish an order, the second one has to follow. So give me one of the 2.
SQT.
Okay. SQT would be RTQ. And then double check that. S and Q, that's 2 arcs to 1 arc. R to T is 2 arcs to 1 arc, and they are listed first and second. So I double check that very quickly just to make sure that what I have marked congruent is in the same position. Same thing for segment QT is congruent to itself, and QT is second, third in both of them. Yes?
Yeah.
And so finally, can I say that QTS and TQR are congruent? Yes, because that goes in order: second, third, first, second, third, first. How's life treating you?
Good.
CPCTC.
See?
Shall we proceed?
See?
All right. Number 3. V is congruent to Y. That's already marked congruent. I see a magic word. WZ bisects VWY. So that means good. Because last period when I was doing this, I saw that WZ was a bisector. I almost marked those 2 congruent. Why is that not necessarily true? Yeah. Pay attention to what we're bisecting. We're bisecting the angle VWY. VWY. So that means that one side is congruent to the other side.
So would you just do like angle W equals
No.
angle W?
Nope. Cannot say angle W equals angle W. Yeah, you have to go the 3 point naming.
Oh, wait, what?
VWZ
Oh, okay.
congruent to ZWY. Do we understand why we have to go 3 letters on that one?
Yeah.
Wait, why do you have to do that again?
Because if you only say angle W, I don't know if you're talking about this angle at W, this angle at W, or the whole angle at W. It's too ambiguous. There's 3 potential ways I could interpret that. So we have to go 3 letters because there's no way, unless you just don't know what this means. But if you understand math, there's no way you can misunderstand what angle VWZ is.
So that would be definition of angle bisector?
Yep. Definition of angle bisector.
You can just say bisector.
You can just say bisector. That's fine. Good. So I have this angle is going to be congruent to this angle. Angle side. We have to make sure we write the side congruent though. WZ will be congruent to itself. And by the way, in just a minute, Matthias' 7th period is going to come in here. So I guess there's a few empty desks that can sit on the floor. I don't know. That's reflexive. That says reflexive. Trust me. And now I have my angle side, so I can name congruent triangles. Give me one. Okay, stop. VWZ. And now with the second one, we have to make sure we get it in correct order.
YWZ.
It'll be YWZ. And that's by angle side. And finally, VW and YW. Are they in the correct positions? VW, YW, yes, they're both first and second. That works out. VW is congruent to YW by CPCTC. Good.
What? Wait. Whoa. This one's a little confusing.
Yeah, the next one's really confusing. I think so far the first five or first three were pretty nice. I think. Let's look at number
All the homework is
4.
on this one, right?
Hmm?
Is all the homework assigned on this one?
Yeah, let's go into all of it because we're also going to have like 25 minutes to work on angle mass. So. Okay, this is another one of those overlapping triangles. I see 3 different pairs of triangles that could be addressed in this one. There's this triangle and this triangle look like they could be congruent. This triangle and this triangle look like they could be congruent. And the ones on the bottom, are they coming? Here they come! And this triangle and this triangle look like they could be congruent. So we have a lot of possibilities. We'll let them settle in and we'll finish this one. Carter.
What do you gotta do?
I don't know. Absolutely. Yeah. Grab a desk if you can find one. If you can't, grab a chair or grab a floor.
Can I sit right here?
Yeah, I don't care. You can just listen to it like you want. Okay, are we settled? Okay, let's knock out number 4 real quick, and then you'll have the rest of the class period to work on the homework. Ms. Mathias, y'all just kind of hang tight. Y'all have already done all 4 of these, right? So if you want a second dose of number 4, you can get that. All right, so first thing, let's make note of what's given. CAE, CAE, that's this big angle here, is congruent to CEA, that's this big angle here. BA, that's this little piece, and BE, that's this little piece. So at the moment, I see a side and an angle. So I'm thinking we either have side, angle, side. Oh, nope, sorry. Woo, sorry, people. Angle, side. And angle, side, angle. Is there another one? I think that's it with angles, isn't it? Yeah, because we have side, side, Okay, that's all of them. All right, so let's see what else we have. Do you see anything else that we can be looking at? Go ahead, Caden. Huh? Where? Yes, but which ones are you looking at? BE. No, I know, but there's 2 sets of vertical angles. You want to go ahead and knock all of them out? Okay.
Angle AE.
Oh, we have a little bit of a problem. They didn't name that intersection. So we would have to introduce a name for that intersection. Or we could number these angles if you really want to declare them congruent. Now, I'm just going to humor you for a little bit. If you wanted to say something like angle 1 is congruent to angle 3. Is that a true statement? It absolutely is. And that is the correct use of vertical angle theorems. It's not going to help. If you put something like that that's true and it doesn't help you, it doesn't hurt you either. I'm not going to take off points for that, but it isn't going to help. And the fact that that point was not pre-labeled is kind of an indication we're not going to use it. If we were intended to use that, they probably would have given it a name to make it easier for us. What triangles do you think we're going to focus on? Let's do that.
ADE and
Yep. I think, where's my highlighter? We're looking at these triangles. A, B, oh, that was bad. E, that triangle, and DAE. I should have used more contrasting colors. Whatever. Are we good? Those are the triangles we're looking at. Like I said, if you have a highlighter or a colored pencil or something, and you want to do that on your test, on your paper to make it a little bit easier for you to process, I'm okay with that. And looking at those, I see something kind of cute. What do I see that's kind of cute?
what? Oh, AE is congruent
Yeah,
to AE.
they share a side. Those two triangles, they overlap, but they share side AE. AE congruent to AE by reflexive. And that was a side. And so looking up here, what we were given an angle and a side. We have the third side. We're looking at side angle side. And I can go ahead and declare my congruent triangles. Somebody give me one.
DAE.
Stop!
What'd I do?
You said DAE.
I said DAE.
Oh, BAE? Oh, okay. BAE. Okay, so let's think. If we're going to go BAE, what we call the second one is very important.
DEA.
So BAE and DEA, I believe that is going to work. And why'd you quit writing? Oh, there it goes. And that is by side angle side. And finally, let's look at those congruent statements. We need AD and EB to be in the same position. EB is first and third. AD is also first and third. That is what I needed. Therefore, we have our CPCTC. AD congruent to EB by CPCTC. Are we good? We good? All right, we have a good 20 minutes. We should get a chunk of homework knocked out in that 20 minutes. If you finish it, just hold on to it, and I'll check it tomorrow. I did go through today for the first time in about a week or so. Thank you, man. We have like 20 minutes. How much? I know. I would if you could take it in one sitting, that's what I would prefer.
Okay. I mean, I can do it tomorrow.
Let's do it tomorrow. Could you come to a video, possibly?
Yeah.
How are we doing? All right. So I put in a few grades today. Keith, I owe you something. Oh, do I have an error? Ah, you got me. There we go.
Bro, what is that? 9. Is that 9?
You might want to make that a clear 9 because next time somebody puts something up there, they may add it to turn it into a 7.
I know.
Or an 8, I mean.
Why is it so much smaller than an 8?
So we're missing Andy today. Is that it? Go attendance. Oh, I never did attendance for you. Whoops. I need to